Problem number 10. The area of a rectangle is 10 inches squared. What would the area be if the length of each side is doubled? Well, I'm going to give you a nice little shortcut to make this easy for you to figure out. If I know the area of a rectangle is 10 inches squared, and our formula for area is length times width, I'm just going to draw an image of a rectangle and give it a length times width that when multiplied gives me 10. So 2 times 5 does give me 10. So if I doubled the length of each side, 2 would become 4, 5 would become 10. My new area would be 4 times 10, which is 40 inches squared. Number 11, triangle ABC with points 2, 3, 8, 5, 10, 2 is reflected over the x-axis. What are the coordinates of A prime? Well, in order for us to determine A prime, we need to remember our rule for a reflection over the x-axis. And we use the rule xy forms x, negative y. So I want to know the coordinates of A prime. Well, I'm going to plug my values for A into this rule. So 2 comes into the rule, and it stays the same. My 3 from my y value comes into the rule, and we take the opposite of it. The opposite of positive 3 is negative 3. So my A prime value would be 2, negative 3. Number 12, triangle UGA with points negative 4, 5, 2, 8, and 0, 3 is reflected over the y-axis. What are the coordinates of A prime? Well, now we're reflected over the y-axis, so we need a different rule, and I'm always going to write out the rule first. It's good practice, and it will tell me if you know the rule in the first place. So xy forms negative x, y. And so this time I take my values for A and I plug them into this new rule. I have an x of 0, so 0 and the opposite of 0, well, that still gives me 0. And then a y of 3, 3, and nothing changed with my y, so it would still be 3. So, reflected over the x-axis, we can look at our ordered pair for A and our ordered pair for A prime, and we realize nothing changes when we reflect over the y-axis. And then you may be asking yourself why that's the case, and that happens to be the case because the point 0, 3 is on the y-axis. So when you do a reflection over the y-axis, any point that is already on the y-axis is not going to change in its values.